What is the Kardashev Scale? How does the scale measure a civilization's technological advancement? What are the three original types of civilization? What challenges do civilizations face as they progress on the scale? Imagine a future where humanity has harnessed the energy of entire planets, stars, or even galaxies. The Kardashev Scale is a fascinating concept proposed by Russian astrophysicist Nikolai Kardashev in 1964. It's a way to measure a civilization's level of technological advancement based on the amount of energy it can harness and use. It has three types. Type 1 controls planetary energy. Type 2 harnesses a star's energy. Type 3 utilizes energy from an entire galaxy. Remember, the Kardashev scale is purely hypothetical, but it sparks our imagination about what civilizations might achieve in the distant future. But what does this mean for us? Are we on the brink of becoming a Type I civilization? And what incredible possibilities lie ahead as we climb this cosmic ladder? Stay tuned as we dive deep into the fascinating realms of the Kardashev scale and explore what our future could look like among the stars. What might we find? Little green men or microbes? How might we find them? Radio waves or strange chemicals in the planet's atmosphere? Something no one has even thought of yet? Over the decades, scientists considering the possibility of life beyond Earth have pondered what such life might look like, how humans might be able to identify it from afar, and whether communication between the two worlds might be possible. That thinking has included developing classification systems ready to fill with aliens. One such system is called the Kardashev Scale, after the Soviet astronomer who proposed it in 1964, and evaluates alien civilizations based on the energy they can harness. Kardashev's scale is a classification system for hypothetical extraterrestrial civilizations. The scale includes three categories based on how much energy a civilization is using. Kardashev describes Type 1 as a technological level close to the level presently attained on the Earth. Type 2 is a civilization capable of harnessing the energy radiated by its own star, and Type 3 as a civilization in possession of energy on the scale of its own galaxy. According to the Soviet astronomer, our civilization would be too young to be able to contact another civilization that would certainly be more advanced than us. The solar system is too young with its 5 billion years, and the first ancestors of today's man appeared only 6 million years ago. The earliest, the oldest celestial objects are between 10 and 14 billion years old. It is clear that the other civilizations are incomparably older than the human civilization. Therefore, the knowledge of these civilizations must be greater than ours, and, he reasoned, they must surely be aware of what we are doing. Kardashev believed it is probable that the present state of our civilization is only one of the stages through which civilizations pass during their evolution. It is thus possible to define civilization on the basis of this universal characteristic, which allowed Alexander Lyapunov to define life as a highly stable state of matter, which uses information encoded by the states of individual molecules to produce maintaining reactions, which Kardashev calls the functional definition of civilization. He therefore suggests thinking of civilization as a highly stable state of matter capable of acquiring, making abstract analysis of, and utilizing information to obtain qualitatively new information about its environment and about itself, to improve its capabilities of gathering new information for producing sustaining reactions. Civilization is therefore characterized by the quality of the information acquired by its operating program, and by the energy required to implement these functions. By information about its environment and about itself, Kardashev specified that it is data about organic or inorganic nature, science, technology, economy, culture, arts, etc. From this definition, he proposed a diagram representing the interactions between a civilization and its environment, and enumerated a number of scientific problems arising from these interactions with the information available in the universe. From this definition, Kardashev drew three conclusions. The first postulated that because of the vast and unlimited set of activities required by scientific problems, the period during which civilizations must transmit and communicate is necessarily long, even unlimited. On the other hand, since our present development covers only a negligible fraction of this communication phase, Kardashev hypothesized the high improbability that we will meet brothers in intelligence who are at the same stage of evolution as are we. After all, highly advanced civilizations know and use the laws of physics to a degree that we have yet to suspect. Kardashev asserted that this last point should be taken into account in the research programs of extraterrestrial civilizations, and concluded that it is very likely that our present state is only one of the stages through which every civilization passes during its evolution. Kardashev then analyzed various models and hypotheses of the evolution of civilization, answering the question of the Russian astronomer Iosif Shklovsky, who in an article published in 1977 entitled "Possibility of the Intelligent Life in the Universe Being Unique," found it strange that the shockwave of intelligence of a super-civilization had not yet reached the limits of the whole universe. Kardashev put forward two explanatory hypotheses. In the first, he postulated that it would not be useful for a super-civilization to expand the space it occupies in order to maintain its activity, and in the second, it is possible that a civilization, instead of dispersing itself in space, would rather continue its activities of information analysis in order to discover new fundamental laws. However, such civilization activities require the use of abundant energy. According to the laws of thermodynamics, an important part of this consumed energy must be converted into radiation of a bolometric magnitude approximately equal to that of the radiation background surrounding the source. The spectral distribution of this intensity must be close to that of a black body. This would be a possible way to search for extraterrestrial civilizations. Such energy consumption would also require a large amount of solid matter for stellar engineering activities, which Kardashev called cosmic miracles. In short, information about the possible existence of an extraterrestrial civilization would come in the form of electromagnetic radiation. With regard to the fate of civilizations, Kardashev saw two concepts, from which two strategies for the search for extraterrestrial civilizations can be derived. The first, which he called terrestrial chauvinism, is based on the principle that civilizations can only stabilize or perish at a level of development close to ours currently reached. The second, which he called the evolutionary concept, holds that civilizations are capable of reaching higher levels of development than that of contemporary humanity. According to Kardashev, in order to capture the significant radiation of an advanced civilization emitted by a megastructure, such as a Dyson sphere, a radio telescope with a diameter larger than the diameter of the Earth would have to be placed in orbital space. Kardashev concluded by predicting that the search for extraterrestrial civilizations would lead to positive results in the next decade, giving humanity access to a vast amount of information about the universe and its evolution over a period of several billion years. The hypothetical classification, known as the Kardashev Scale, distinguishes three stages in the evolution of civilizations, according to the dual criteria of access and energy consumption. The purpose of this classification is to guide the search for extraterrestrial civilizations, and this on the assumption that a fraction of the energy used by each type is intended for communication with other civilizations. To make this scale more understandable, Lamarckian compares the speed at which a volume of information equivalent to 100,000 average-sized books can be transmitted across the galaxy. A Type 2 civilization can send this data using a transmission beam that lasts for only 100 seconds. A similar amount of information can be sent across intergalactic distances of about 10 million light-years, with a transmission time of several weeks. A Type 3 civilization can send the same amount of data to the entire observable universe with a transmission time of 3 seconds. Kardashev's classification is based on the assumption of a growth rate of 1% per year. Kardashev believed that it would take humanity 3,200 years to reach Type 2 and 5,800 years to reach Type 3. What are the three original types of civilizations? A Type 1 designation is a given to species who have been able to harness all the energy that is available from a neighboring star, gathering and storing it to meet the energy demands of a growing population. This means that we would need to boost our current energy production over 100,000 times to reach this status. However, being able to harness all Earth's energy would also mean that we could have control over all natural forces. Human beings could control volcanoes, the weather, and even earthquakes. At least, that is the idea. These kinds of feats are hard to believe, but compared to the advances that may still be to come, these are just basic and primitive levels of control. A Type 2 civilization can harness the power of their entire state. Several methods for this have been proposed, the most popular of which is the hypothetical Dyson sphere. This device, if you want to call it that, would encompass every single inch of the star, gathering most of its energy output and transferring it to a planet for later use. Alternatively, if fusion power had been mastered by the race, a reactor on a truly immense scale could be used to satisfy their needs. Nearby gas giants can be utilized for their hydrogen, slowly drained of life by an orbiting reactor. What would this much energy mean for a species? Well, nothing known to science could wipe out a Type 2 civilization. Take, for instance, if humans survived long enough to reach this status, and a moon-sized object entered our solar system on a collision course with our little blue planet, we'd have the ability to vaporize it out of existence. Or if we had time, we could move our planet out of the way, completely dodging it. But let's say we didn't want to move Earth. Are there any other options? Well, yes, because we'd have the capability to move Jupiter or another planet of our choice into the way pretty cool, right? So we've gone from having control over a planet to a star, which has resulted in us harboring enough disposable energy to essentially make our civilization immune to extinction. But now, on to Type 3, where a species then becomes galactic traversers with knowledge of everything having to do with energy, resulting in them becoming a master race. In terms of humans, hundreds of thousands of years of evolution, both biological and mechanical, may result in the inhabitants of this Type 3 civilization being incredibly different from the human race as we know it. These may be cyborgs, with the descendants of regular humans being a subspecies among the now highly advanced society. These wholly biological humans would likely be seen as being disabled, inferior, or unevolved by their cybernetic counterparts. At this stage, we would have developed colonies of robots that are capable of self-replication. Their population may increase into the millions as they spread out across the galaxy, colonizing star after star. And these beings might build Dyson spheres to encapsulate each one, creating a huge network that would carry energy back to the home planet. But stretching over the galaxy in such a manner would face several problems. Namely, the species would be constrained by the laws of physics, particularly light speed travel. That is, unless they develop a working warp drive, or use that immaculate energy cache to master wormhole teleportation, they can only get so far. As we wrap up our cosmic journey through the Kardashev Scale, take a moment to ponder the vastness of our universe. From Type 1 civilizations harnessing planetary energy to Type 3 civilizations controlling the power of entire galaxies, we've explored the incredible potential of advanced societies. Remember, the Kardashev Scale isn't just about energy. It's about our place in the cosmos and our quest for knowledge. Until next time, keep reaching for the stars. If you found this exploration of the Kardashev Scale fascinating, don't forget to hit that subscribe button and ring the notification bell. Join our cosmic community as we dive deeper into the mysteries of the universe. And hey, maybe one day, we'll be discussing Type 4 and beyond. As we sign off, consider this. Are we alone in the cosmos? Could there be Type 2 civilizations out there, beaming energy across light years? Keep wondering, keep exploring, and keep your telescopes pointed toward the heavens. Until next time, fellow cosmic adventurers.